All right, so if I go around this loop, I have, let's see, minus 9, minus 10, plus 12. So that's going to give me the Vx equals 2 volts. So that agrees. Okay. So this one, it doesn't really seem like there's anything to solve for. So let me show you what they were also asking for in this kind of problem. So it's also common in these problems to label the nodes, even though they're just simple nodes, right, in terms of current. So these are labeled A, B, C, D, and E. So what would be a common sort of homework problem would be to say, let's find VBD. All right. So that is code. That's in code. So the code works like this. So I'm going to write it over here, VBD. So that's going to be the first node. That's where we would put the plus, the red probe of our voltmeter. And the second node label is where we're going to put the minus, the black probe of our voltmeter. Okay. So when you used the voltmeters last week on the snap circuits, you could measure what was supposed to be 3 volts on the battery. And if you move the red and black ones back and forth, you got +3 or -3. Right? So part of the code here is that I want to measure from node B to node D. Sorry. So from the voltage from node B to node D. All right. So this is the kind of vocabulary, the way electrical engineers talk. All right. So you want to start talking like an electrical engineer. All right. So this is how, when you're working together on homework and you're saying, I'm stuck on this problem, you need to communicate with each other. I'm trying to find the voltage from node A to node C, and I keep getting the wrong answer, or I keep getting the wrong sign. So you need to be able to describe to each other what you're working on, what it is you're trying to do. And this is part of that language and code that we use. So labeling the nodes and then labeling a voltage. All right. So what you might see on a diagram, they might put a label across the middle of the diagram that says VBD plus and minus, and they assume that you understand that you're going from node B to node D. Right? And you can think of that as measuring it from the red to black. Even though we called this a single loop, we can choose to break it into even smaller pieces with our voltmeter. Right? So you can imagine, let me see if I have another color pen here. Perfect. I have red and black. Okay. So if I had my red and black probes, I could measure this voltage, right? Or I could measure this voltage. Or the one I want to measure would be like this. So I can calculate that by writing a KVL loop if I don't have a voltmeter with me. And the way I would do that is to go around a loop so that I include this measured value as part of my equation. Like I did here, I could solve for Vx. I'm going to do the same thing where I can solve for VBD. Right? So I can write a KVL. Get this right up to the top. All right. Let's say I go around the left side. So I'm going to go through the dependent source, through this resistor. I'm going to jump across. I'm going to put this in my equation, and then finish my loop. So that would look like -8, -1, plus VBD. That's my unknown. I'm jumping over to the corner, and then I hit the -1 again down here, and then I'm back to node E, so that has to equal 0. So that tells me that VBD equals What do you think? How many volts?
10.
10. Thank you. All right. We can double check that by writing another KVL. Just for fun, we'll go the other way around. We'll start at D, and we'll go around, and we're going to do kind of a triangular loop here, up and across, and then back through the VBD. So I would hit the minus side of 12 volts, and the plus side of Vx, which I know is 2 volts, and the plus side of VBD equals 0. So VBD equals 12 minus Vx. 12 minus 2 is 10 volts. So I double-checked my answer.
Why did they put VBD
As positive? Because the way I went around my loop, I hit the plus sign first. So when I went clockwise this way, I hit the plus sign. When I went counterclockwise this way, I also hit the plus sign first. Okay? Do you want me to write one going the other way? Just for fun? Let's go the other way. So I would hit minus VBD, and then I would hit minus Vx, and plus 12 equals 0. And that would give me the same answer. I would have minus Vx plus 12 equals VBD, and I would get the same 10 volts.